Yeah, I'm very pleased to be here. Very exciting presentation I'm going to do for you today. I'm trying to keep the slides to a minimum. We're talking about MDAccess for DOORS, which is basically a Java API for DOORS. So it's going to get technical. We're going to jump into Eclipse and see some stuff and execute. So I will try and keep us down to 12 or so slides. So let's just jump right in. First, why did we build MDAccess? I love this picture because I think it says it all. Why did we build MDAccess? Well, DOORS was probably a great tool modern maybe 20 years ago, but as you see now it's a bit dated. The language is a derivative of C. You can see the environment for editing the DXL code is a bit rough, a bit hard to use. So in summary, that's basically why we decided to jump into MDAccess, and hopefully none of this is new and you've seen this editor before, and which has driven you to look for a different solution. So it comes down to the question, what's easier, to develop in this DXL or to use Java? Right, so why did we get there? Well, DXL, it's a scarce population, right, and it's not growing. Typically, DXL probably 10, 15 years ago, it's when a lot of the DXL expertise was coming on board and being grown, but there's not a lot of people coming out of school especially, but even in organizations that are jumping in and starting to do DXL code, so you're kind of fighting for a smaller set of people who can do some of this DXL, which leads to a couple of things around the cost of this. These people are not cheap. They're usually more senior people, so they are expensive themselves, but then their productivity is really not that great given that environment, so it's difficult and expensive to build and to even maintain the existing solutions, which ties into the third point about the lack of development tools. DXL just has that editor that I showed you. Of course, Sodius, I don't know if you guys are aware, but Sodius has a DXL editor, which is Eclipse environment for doing this DXL stuff. It's great. It's light years ahead of what I just showed you, but it's not up to the level of full IDE for Java, for instance. So going to Java, easy to find skills. There's Java programs are a dime a dozen. There's powerful IDEs, whether it's Eclipse or anything else that could be out there. And also, I think important as well is that it's probably tying in with a lot of the existing code, or it's easier to get Java to other stuff type bridges than it is DXL or DOORS to type bridges in place. So it's going to let you more cost effectively build your solutions and also tie it in with the rest of the existing infrastructure that your organization has. So that was kind of the introduction, let you guys know if you're in the right spot or interested in this topic. So let me tell you who we are and why we're talking about this. So Sodius is, I guess, really well known for being integration experts. That's what we do. That's what we've done since really our inception. It's for integrating data across the product lifecycle, and this is typically engineering design type data. A lot of stuff around UML models and integrating those with other things. A lot of stuff around architecture frameworks like DODAF or NAF. MODAF, etc., and tying that stuff into the rest of the artifacts or applications in your engineering departments. We're a strong technology company. I think there's probably only maybe two people in our company who are not engineers. We're just a solid engineering company, and we like to work with technology partners. I listed our largest here being IBM. IBM, we do a lot of stuff around Rhapsody, as you may have figured out from our introduction about myself. We've been doing that for 10 years almost, or maybe even more. Yeah, probably 12 years now. Right around Rhapsody, so we do an ADA code generator, an XMI toolkit, so how do we exchange information between those Rhapsody UML models and other tools. The AutoZAR toolkit as well, so creating the AutoZAR XML files from Rhapsody. And all of this stuff is built on a Rhapsody add-on called the Rules Composer, which lets you write your own code generators such as Ada or something else, or your interchanges for Rhapsody using our platform, which I'll get to in a second. And so all of those are IBM products. So you're probably saying, who is Sodius? I've never heard of them, but you may be touching some of our technology either through IBM or some of the other partners we have. We're technology suppliers also to Know Magic, right? Another UML tool called Magic Draw. TaskTop as well. They do synchronization of your lifecycle data. I'll have a slide at the end, and I'll get more in detail about those guys. A couple other ones I wanted to name as well were IKV and BTCES. They're both out of Germany. And the reason I kind of threw them on here is they are OEM. We provide our MDAccess for doors technology, right, our subject for today, to those companies. And they do, IKV does some ISO 26262, right, automotive standard type Workbench, and they use that to integrate the doors using MDAccess. BTCES, they do automated testing, model-based testing, really. And they, again, tie into doors and integrity, also using our technology. So as we're talking about other MDAccess for doors customers, you'll also find a couple large automotive OEM companies that use that as well. One example, they're using RPE, which is a reporting tool for doors information. It was too slow, so they use MDAccess for doors. Another one is probably the largest automotive supplier, uses it as well to exchange information between RECIF and doors and integrity as part of their process of interacting with their OEM and their suppliers. So finally, besides all of the behind-the-scenes type work there, we also sell directly our own products. So around doors, there's DXL Editor, which I mentioned earlier, which is an Eclipse environment for this DXL language. There is Branch Manager for doors. It tries to kind of make up for some of the shortcomings in managing multiple evolutions of requirements, whether it's for different product lines or just different versions of the same product. MD Connect for doors lets you drag and drop requirements inside of Eclipse into model elements in Rational Software Architect to do types of linking. MD Workbench is our generic platform that lets you do any of these code generation or interoperability use cases. And then MDAccess is what we're talking about today, which is the ability to read and write information from different applications, in this case doors. I will note that you probably see a lot of MD and wondering if this is doctors or why we're talking about MD, but MD really comes from a model-driven approach. And we kind of look at things conceptually as models, which just helps the understanding and really put your head around the data structures of these tools. And so that's where the MD comes from. As Kara said, my name is Tom Capelli. I'm running our North American operations. We're actually a French-based company with a U.S. subsidiary. I have Sebastian Boucard on the phone, who is our head of research and development out of France. He's here to really just keep me honest and answer any of the deep technical questions that may come up. So let's jump into this. What exactly is MDAccess for doors? Well, quite simply, it's a Java library. It's just a Java library that you're going to interact with, make these Java calls, and underneath the hood, it's going to generate the corresponding DXL that doors needs to execute what your intention was. So underneath the scenes as well, it's going to open doors invisibly, execute the DXL script, and pass it back. So IBM has a Ready for Rational program, which is the appropriate way to deal with tools. And for doors, you'll see that you need to use the client to execute this. And so communication is through the doors client, but that client first is headless, right? It's invisible, and that's configurable actually. This client does not have to be on every one of your workstations. It can be on a server right next to the door server. And so it's kind of just an afterthought that it's actually through the client, but that is the case. So it's generating DXL that represent what you want to do in Java, and then it's executing and bringing back those results. And again, we'll see all this happening live. And beyond that, though, it's not just a bunch of APIs we're throwing at you to tell you good luck figuring this out. We also provide this Eclipse environment with some productivity tools, and notably the Doors database viewer, which is going to help you write whatever integration or whatever use case you have for your doors data, because it's going to let you visually understand how that data in doors is connected to each other and let you navigate, search, and other stuff. And so we'll highlight that as we go through this. So the first thing we're going to talk about is reading from doors. As I said, this is pure Java, so you are going to just use standard Java getters to access the information. So you want to, and I assume we have a little bit of vocabulary in common between doors, and so doors, just at a high level, basically has folders or projects that contain formal modules, and formal modules are really what you almost consider a document, so it's kind of all of the statements that are in a document. And then inside of a formal module, there's objects. Each object you traditionally think of as a requirement, but it's basically breaking up a document into all of the individual statements, and each one of those statements becomes objects. And then objects can be related to other objects with links, which are contained in link modules, and that's about it. I mean, there's more to it, but in general, that's what it is. And so if you're on a object, you can just say object get outlinks, and it's just going to return a Java collection of the outlinks. And you can ask an outlink for its target by saying outlink .get target. So you're using standard Java getters. There's nothing crazy about the API. It's very standard and very simplistic in letting you get to that information. One of the things we've worked a lot on is optimized reading for a subset of the database. And there's a couple of things here I'll highlight. There's a full reading of a set of the database versus on-demand. So the first case is I know that I need to read a specific module out of doors. So we can be very efficient in how we request that information from doors and how we bring it back, knowing that we need all the information. So that process is highly optimized so that you can select a subset of your entire database, because you probably do not need the whole database, and you can focus in on either the project or the formal module or the folder that you're interested in, and we will very quickly read that in and give you basically a Java object tree you're going to use these Java getters to access. Sometimes, though, you're not exactly sure what you need, because you could say, I need to read this formal module, but you want to get to the outlinks. You want to see who all those objects are linked to, and so you'll use an on-demand capability that's built in. And so on-demand means as I execute that Java getter that says outlink.getTarget, it's going to hit the doors DXL API, and it's going to figure out who it's connected to and then bring that information over. So these two are not exclusive. You usually use a combination of both, where once then you figure out who the external link to module is, you then do an optimized read for all the contents of that module. So I'll highlight a bit of this is in the next step as we do the demo. So while we'll, and I promise I'm one slide away from actually seeing something, but I just show you this little bit of an introduction before I kind of throw you into this Eclipse environment. So I alluded to earlier this database viewer, which is really just a productivity tool for the developer so that he understands the context he's working in and where to get the data that he wants. So that's what this screenshot on the right side is. It's just showing you the view that's created in Eclipse to view doors data. So the upper right pane, which says instances, hopefully you can all read this. I tried to make my resolution as small as possible. It's a list of what's in your database, and it shows you the containment, right, the links between objects, and you just kind of expand it like any tree view. So I see here that there's a project called Design V1.1, which is a project, and it has some owned items. I opened up the owned items. I can see that there's a design folder, and I can see there's a couple owned items, and I clicked on one of them, which is a formal module. So just by navigating here, I can drill down and see how things are related. On the bottom side, where it says properties, the bottom portion of this view, that is showing me the detailed properties for whatever's selected. You can almost think of this as a model debugger, because now I clicked on a formal module and this view is showing me everything, every property that's on there. You can see like last modified by, last modified on, the mode, the name, the prefix, the URL, right? Anything that's standard for a DOORS object, or in this case a formal module to have, you're going to see here. It's a little bit cut off, but towards the right of that there's references, so you see those same links that you're seeing up above. Including, if you've written custom attributes, you'll see that information as well directly here. On the upper left, where you see types, is basically just a summary. Here are all the types that I read. So in this portion of the database that I chose to read, I can see that there's 9 projects, there's 2 formal modules, there's 644 instantiated attributes, right? These are your custom attributes. There are 35 enumeration literals, 6 baselines, etc. So that's just really giving me a count, so I can quickly jump around and say, oh, I want to see the folders that are there. I want to just scroll through the formal modules, and you can just quickly navigate. So you can do plain text search. You can actually get a visual out of this. We won't go into all the details, but it's really there as a model debug tool that's going to make your life easier as you're writing your integration use cases. All right. So let's jump directly into Eclipse. And this is our little environment, which I referred to earlier as MD Workbench, right, the model-driven workbench. So you'll see here we kind of call everything a model. We're interested in DOORS, and if we just look through a few things, here is that same view that I was trying to show you earlier, where we have all the instances here. And so you can click through and say I have a design folder. In that design folder there's one item, an architecture formal module. You see the properties here, shows me all of that information, the URL, the prefix. I can click, I can look at all 130 objects that are in there, and typical things you'll see on a object, like object heading, object identifier, object kind, object level, object number. And they all have different types, right? Like last modified on is going to be a timestamp. Things like object heading, object text, it's actually formatted text, right? Which we can think of as, you know, like a rich text field. There could be images, etc. And here you can see the instantiated attributes. There's a low set for design risk. There's an old ID, and there's some other things. So it's really just debugging, showing me everything that's on these objects. So the other thing which is part of this is this thing here, as I said, where I can see the baselines that exist. I can see the attribute definitions which are here, the formal modules, and that just lets me navigate kind of across all the same types of objects at once. So one of the things that I talked about earlier was the ability to do optimized reading, right, all at once, or kind of on demand as you go, as you decide you need it, we'll go get it. And so I can show you a bit of that. So again, this is a development environment, and what I've done here is just said, let's reread the database. And it's our kind of default user interface that just shows us our DOORS database. If you looked, here's our DOORS database, here's the projects, Design V1, Design Sandbox. There is a project here called Design V1. There's a folder that has 2 formal modules. So all I'm going to do is just read this portion of my database. So here, you probably can't see this. There's these little boxes here, but if I unselect it, maybe you can see the difference. They're blank, meaning exclude. Don't read any of that stuff. As I navigate, I can say, I want to read all of my architecture because I know that formal module, I'm going to need everything that's in there. And it may be related to CI structure, so I will read that on demand. So this one is complete, this one's on demand, this one's exclude. I'll never read this, I won't even know it exists. So, and by the way, if you're looking at this, I did steal these architecture formal modules and stuff from the DOORS sample database. So don't, I'm trying to give credit where credit's due. So now if I hit finish, it's going to show me exactly what we saw before. We're going to see a bunch of attributes, and if we started at the top, there was this design project, It only had one item, which was a design folder, which had the two owned items, right? So I had formal module for architecture and CI structure. So if I navigate through here, you'll see that all 138 objects are there, right? And so it kind of read through that all in here, and it was pretty fast. I mean, I'm running this, by the way, on just a MacBook. I'm running this inside Parallels and a Windows inside of it, and it's pretty fast. The other thing is now I have CI structure where, you know, for instance, you can look and see that all objects, it doesn't know how many objects it has, because all we said to do is have this thing around in case I need it. So now we get into the on-demand portion of this where as I execute that get all objects, now it hit the database, and now it opened it up and said, oh yeah, here's what's there. There's all of those. And so now as I do that same thing here, it'll, you know, navigate, and here it's hitting the database trying to see what's there. So that's how these two things work. It's a combination of optimizing where you know you need information, but being flexible and grabbing the information as you need it going forward. And all of that is configurable with the API. We just happen to embed it in an application here for the user. So again, I'm a developer. I want to understand my data before writing something. All right. Sorry, but we're going back to slides now. So accessing DOORS information. There are a set of Java classes that represent those DOORS types. Right, so there's a Java class for formal module, an object, a link, a baseline, a link module, a view. Anything that conceptually you think of as being element in DOORS has an equivalent Java class. To access that information, we're going to just use the standard getter. So here I have a formal module selected, and so for any formal module I could say get description, get current view, get the baselines, get the created on, created by, get the name, etc. And like for an object, I can say object dot get heading, get in links, get description. All right, so if we went back and look at that, you can get that here as well. So this is part of that environment where if I double click on DOORS, I can see all of the types which are here. So again, I have like a formal module, and I can see that formal module actually is a subclass of a simple module. If I look at a module has attributes, it has a name, other things. And a module, importantly, has all objects, right? These are the requirements basically contained as an object, so I can double-click and look at an object. And an object has an absolute number, and I can see this is an integer, has a bunch of objects, nested objects, object level, object kind, object identifier. So this is where those getters are coming from. We provide this environment that shows you the types you have, right? Those are all your Java types, and what type of information they have that you can ask for. So let's jump in and do something here, and I apologize, these are canned demos, but that's why Sebastian's here. He didn't want me typing anything live. But these things are really easy. I tried to make them real simple, but they are pre-canned, but we'll walk through the code here in a second. But here's what we're going to try and do. Just as a simple example, we're going to export from DOORS. So I think this one's pretty common. We have a bunch of requirements that are formally captured in DOORS, they're approved, they're signed off, but we need to get them other places for other uses. So we need to export from DOORS, and typically Excel is a great place to do this. I've actually seen a lot of people use Excel to put dashboards on top of these requirements, how many are approved, et cetera, over time. So I like this use case. The basic formula we're going to use is we could export multiple modules. Here I just take the first formal module that I happen to read. I create one sheet for that. And in that sheet, I throw one row down for each object, and I throw whatever values that I think are interesting. So if you look at column A, that's object heading. Column B is object text. Column C is object short text. Column D, I put the absolute number. And then in E, I put a custom attribute value. And if you remember from just before, I had highlighted a custom attribute called design risk. That's what's going in column E. So that's all we're going to do. Let's just write a simple rule set, as we call them, to export from DOORS into Excel. And just like those cooking shows, everything's pre-made. But I'm going to step through it. There's not a lot of lines here. Basically, as I said, MD Workbench is the engine that's kind of running, doing all the dirty work for us. So basically, I just create an MD Workbench, and then I'm going to export to Excel. That's all that's happening. So exporting into Excel, starts at line basically 64, kind of goes down to line 100. So there's 40 lines of code, including blank lines and tries and catches and that stuff. But I'll walk you through each of these lines. So, and by the way, this is pure Java. There's nothing up my sleeve. That's all this is. I just created a blank class, and I just have the right libraries in my class path. So reading from doors, you first need to get the meta model for doors. I create an empty model, and then I say model read from a connector that I've chosen. So a connector here is application, which again, you could set a bunch of properties on that to say, don't show it to the user, pre-select. Here, I know exactly the name of the modules I want, and here's what I want on demand, here's what I want to exclude. All that can be done programmatically. Here, I just throw up that same interface just so we can kind of choose it on the fly. Then in this doors model, I say, give me all formal modules. So now I have all the formal modules that I read, and I grab the first one. So hopefully there is one, otherwise nothing's going to execute, but if I choose one in my reader, it's going to show up. And so now I need to kind of prep the destination, this Excel workbook. So what I will do is create a new Excel model, and in there I'll create a new workbook. For that workbook, I'll create a sheet, and I'll give that sheet the name of that formal module. So if I looked, right, again, I did control space, which is kind of the, I forget what it's called, in-place help from Eclipse. Here's everything I can do with a formal module. So in case I don't remember when I looked at the model viewer itself, I can get the created by, created on, all that information. Here I just chose to give me the name. So now I have my workbook prepped with a sheet that's empty. I know which formal module I'm operating on. Let's iterate across all of the objects of that module and create a row in my sheet for that. Then in that row, I'm just going to add the cells as we discussed, which is get object heading, get object text, get object short text. And as you can see, these are rich text, as I alluded to. Like they have color and other strike through and all stuff. We just converted to plain text, so that's all I want in Excel. And I get the absolute number. So with that, I added one more column, which is the attribute value. So I took my object and I said, give me the attribute value. And here I created a constant, which was design risk. So I'm getting the design risk, and I'm putting that in the final row. And then I write out Excel using a writer which writes out an actual .xls, write an Excel workbook, and I put that in the workbook name, which is just design export.xls, which is that file right there. So that's it. I read a portion of my database, and then I dump out object heading, object text, object short text, get an absolute number, and this design risk value. So I will just run this, and it's just an Eclipse Java application. I'm running this, the main class, I'm running main. I'll just hit run. And what it does is it gives me that same viewer, which basically everything was on demand by default. I don't want to read the whole thing. I want to read this one. So I'll put complete. And I'll finish. And if we look at our console, we can see it terminated. Right, so if I look here, November 13th, I'm guessing that's right now, 9:31. So again, nothing's on my sleeve. We actually wrote that thing. If I look, oops, it opened it up over on this screen. Here is what that is. So there was what, like 130 objects or so, 138. So I have 138 rows, which is not a surprise. And object heading, object text, object short text, absolute number, and this mystery attribute design risk, which ranges from low, medium, high. So in those 5 lines of real code, we spit some stuff out from doors, and we could have gotten fancy. We could have had formatting, styles, and other stuff, but that's pretty simple. The other thing you could do, instead of opening directly in Excel, we could open Excel as a model, right? Once again, we're model-driven. So you could go through it this way and say, here's what's in that spreadsheet. I have a workbook that has that sheet called architecture, right, the name of the formal module. It's got 5 columns. It has 138 rows, and I could click down through the cells, look at that cell, look at the properties of string, has a body value, could have a formula, etc. So that is a combination of the Java API, which just happens to be running in Eclipse. I actually thought about having standalone Java so you could really see it was standalone Java. But it's running in this environment as a developer where you can put breakpoints in, debug, step through, do whatever you need to. All right. So let's switch just a bit now. That was reading. And really, what I covered there is extremely basic, and I understand that, but there's nothing more complicated to get any of the other information you need. You just need to know where it is, and then you execute the appropriate Java getters to get that information, and then you put it wherever you want. So let's switch into writing. I got another example here, but first let me educate you on how the writing works. So writing has a different approach because it has a slightly different need, where writing is typically more update-based, and so it's fine-grained updating. I just want to get in and update an attribute value, or add an object to an existing module, or create a new baseline, things of that nature. So we have these Java command classes. So it's a small direct interaction with doors, where the DXL is executed as your Java code executes. So this is contrasted a bit with what we just saw with reading, because in reading what happened? We asked for a portion of the model, which spit off a whole bunch of DXL code, brought that information back, and then we kind of played with the values until we hit maybe an on-demand part. Where this is, as you're executing these commands, it's directly going off to doors, executing that and bringing back the values right there in process as you're going. So typically you would think of commands as kind of bundled low-level DXL statements that execute a single higher-level function, like creating an object. There may be a few different DXL lines in there to create an object or to add a view or something, where a command kind of bundles it up and gives you one Java statement that kind of does that and hides all that complexity from you. So command classes, here's an example I wanted to throw up here. A command is a one execution sent to doors. So I'm going to create a command, I'm going to prepare it, tell it what it needs to do, I'm going to ship that off to doors to execute. But commands can have multiple steps embedded. So you can almost think of it as your command being the transaction. So here I'm creating a command, and apparently I should have my screenshot a little wider, which at the end of this command is going to save and close this module. So the first thing I do is I say, here's the module that I want to work on. I get the module and I say, we're going to put this in edit mode, and at the end I'm going to save and close, and now here's what I want to do. I want to create an object fragment, I want to create a table fragment, I want to set an attribute value, maybe close a discussion fragment, and then here I'm going to run. And it's going to shoot off the doors and then come back. So I kind of prepare basically a transaction of statements that I want to execute in doors, so that if I didn't make any mistakes and there's no errors, it completes, it saves, that transaction is done. If it does, at least I get an error I can catch, and I didn't corrupt or put myself in some unknown state by saving at some intermediary spot. So those are commands, and if you looked, I tried to kind of copy our Java doc over here. Don't know how many of you can read this, but there's a ton of commands. There's actually another page after this. These commands are all of the functions we needed first for ourselves. And I probably should have mentioned that. We're the first customer for this. I showed you the list of 3 or 4 different products we have around doors. We basically built this product for us. We needed a more efficient way to get the information, and we built out a lot of this infrastructure for our own needs, and a lot of these commands are built on what we needed to get access to. And then as we added on the rest of this user base, we flushed it out. And so these commands cover probably the majority of what you need to do. And if not, it's very easy for us to add them on request. But you should probably have everything you need, I would guess. Things like I need to create a module, create a folder, create a picture, create a type, delete an attribute, delete a picture, give you an external link reference, purge an item, resize a table, save a module, soft delete, update an attribute fragment, update a type, right? So there's all these commands that are there. You just kind of need to pick out which ones you want to be doing, and then you just say command execute, and we'll take care of all the dirty DXL. So once again, let's go back into Eclipse. And what we're going to do now is I have another use case here, which is writing into doors. So that Excel that we just generated, we're going to hand that off to a non-doors user. That's why this guy is smiling. He's a non-doors user. He just gets to work in Excel. This non-doors user is just going to update the spreadsheet. And remember, I had that column which was design risk. He's our risk manager. He's going to update that column, and we're going to suck that back into doors and update doors for him so he doesn't even touch doors. So we import those changes back, and everyone's happy and they still have that smile. So let's go back into Eclipse. So now that we're in Eclipse, we're going to continue. We're here. I said export to Excel. We're kind of done with that, so I'll comment that out. And I want to update from Excel. What do I have open here? So we're going to go into this, and for example, if we looked at doors, no pun intended, into properties, attributes, we can see design risk on door is low. Do we have one that's different? What do we have? Oops. Properties, I'm just trying to find some that's different. Here's a medium. So we have a low, we have a medium. This one is exterior is medium. So I just want to have something that we can check, make sure that we're doing the update we think we are. So if I went and I looked at our spreadsheet, and let's open that up again in Excel. Here it comes. We do see, in fact, that the first one's low, medium, high, low, doors is low, etc. And let's say we're just good, and everything is low. We don't have any risk. We know what we're doing. We've driven a car before. All right, and so we'll make all those low. So now I am Joe, doors non-user. You pass me the spreadsheet. I look it over and say, actually, all those are low now. We've handled all that risk. I save off my changes. I send it back to you. You come here and you just execute this update from Excel. So as I did this, we just rerun the same Excel export for doors. And we'll go back to our console. So what it's doing now is, well, I didn't even tell you what it was doing. That's funny. Let's actually look at the code. Maybe so the magic just happened, right? It terminated, but you have no idea what it did. Let me fix that. So update from Excel, same thing. Pass in the Workbench that does all the magic. I create a doors application. So this is where I configure how I want to get to doors. So I could connect to an open instance. I could connect on different servers. I have my doors path here to the executable. I have the port and server that I want to go to. Here's the user I want to log in as and the password. So I'm kind of setting up how I want to connect to doors, and I create this doors application based on what you tell me here, right? So this could be information passed in on a command line, hard-coded, or in some config file. But anyway, I now have a doors I can play with. I have my command runner, right, who's going to be doing all the dirty work of sending those commands over to doors and bringing them back. And here, the first thing I'm going to do is just read my spreadsheet. So I create a new model for Excel, and then I read from that Excel workbook with that same worksheet name, and I get all the instances of the sheet, and I get the first one, right? So I'm grabbing the first sheet that's in there. I then find the module, which I've hard-coded the location, that has the name of that sheet in there, right? So this should be that architecture formal module. And I create an edit command, which I'm going to save and close at the end. So now I'm going to edit my architecture module. So all I do is these 4 lines, which are now going to say, give me all the rows in Excel. I better have at least that design risk column there, so I need at least 5 columns in order to continue. So now all I do is I just go through and get the values and say, get the absolute number from column 4, right, which is index 3. So I say rows, get the cells, get the fourth one, get its value, make it an integer, that's my absolute number. Then I can go look in the database and get that object reference that corresponds to that number. I get the value in cell 5, and that's my new value for the design risk. And then I set the attribute value for my attribute name, which was design risk, to be the value on column 5. And then I run, right? So I created one command, and I added a bunch of little fragments here, one for each object, and then I execute them all at once. And that's what the terminated is. And so if I actually went back and looked at architecture, exterior I believe was high. And if I looked at properties and I looked at attributes, I can now see it's low. So this kind of worked. I could go through, but I find that user interface a bit cumbersome. We'll do it a little bit more efficiently here, where I will reread here. And again, I don't want all that. I just want to read architecture, and if I do finish, I can look at those instantiated attributes. Well, actually, we'll go down object by object. I could look at my formal module, all objects, and the properties, and I look at instantiated attributes. I can see design risk is low in the first one. It's low on the second one, it's low on the third one, it's low on the fourth, it's low on the fifth, right? So I successfully updated my status without my risk engineer having to go into DOORS himself. I was able to pass him a spreadsheet, he did it offline, and I took care of the updates for him. All right, I think I'm doing okay on time. Right, still that smile. So, just the summary of what I just showed you, right? MDAccess for DOORS is certainly, looking at the second line, it's a pure Java API to read or write from DOORS. But beyond that, it's some productivity tools around that that are going to help you write those DOORS applications more productively. It comes with flexible licensing. We do fixed node floating, just an enterprise-wide license we've done. We've done SaaS licenses through our friends at Cloud One. If you don't know Cloud One, they do rational tool hosting in the cloud. They have our stuff. And there's OEM pricing as well, where if you're doing an application yourself, you're providing to others, you can embed our software. So licensing is not an issue. We always find a way to make that work. And then as you saw, we hinted at how you can get to Excel. You know, there's other supported applications besides DOORS that are in this MDAccess family. The UML tools like Enterprise Architect or Software Architect or Rhapsody, Magic Draw as well. There's System Architect as well for the System Architect users out there. That's always a bear to work with, but you get this productivity environment for that. PTC Integrity, on the same level, you can integrate that into your applications, or just plain old XML. So, you know, the one thing I would say is this is MDAccess for DOORS, which I'll call, I guess, legacy, as opposed to next gen, right? DOORS next gen is a different beast. It's a whole different platform. This is not MDAccess for DOORS Next. This is clearly MDAccess for DOORS Legacy. And here is our last slide. You guys made it. Task Top Sync. I will just say briefly that those of you sitting here saying, "Holy cow, is that guy technical? I was trying to get away from programming, and here he's just changing environments." That's a different use case where if you don't want to program, you just want to configure, you want updates to happen automatically between your DOORS information and other applications. One of our OEM partners, TaskTop, we've worked with them to embed this ability to read and write DOORS into their sync platform. Now their sync platform syncs data between quality information to task information, project information, like from RTC, and you can see the list here. So they can sync information across any of these, Rally, JAMA, Rational Team Concert, HPQC, etc. Kind of behind the scenes automatically on a server. So you configure it once, and it's not programming, but you still have to say what do you want to go where. That's another option, which if Cara is nice enough, maybe I'll get a chance to do another webinar, and I can walk you through that with the TaskTop guys, because that's a different approach, where it's out-of-the-box synchronization, which is a bit different than what MDAccess is, which is a toolkit. You still need to program, but it's just a much healthier programming environment. Here's my contact information as well. If you have any questions, give me a call, send me an email. Thank you for your time, and I guess we will open it up for any questions that there may be.
Okay, well, thank you so much for that presentation, Tom. We do have a few questions. I'm going to go ahead and start reading them. Does the Excel import functionality support rich text and OLE objects? I'm not sure what that word is, OLE objects. Does this functionality use the clipboard to transfer that data?
Sure, I'll let Sebastian answer that. And by the way, it's OLE objects.
Okay.
Sebastian, can you jump in?
Yeah, so we do support the rich text as demonstrated by Tom today, and the OLE objects within DOORS. For those who don't know, when you want to attach documents in your content in DOORS, there's a wrapper which is called OLE object to embed the document in DOORS. So this is supported by MDAccess for DOORS for both reading and writing. And then for Excel, you will have a subset. We do support the rich text, but then OLE objects, you won't be able to transfer them from DOORS to Excel. But for the use case demonstrated by Tom, really the important thing is on the content, on the textual content itself.
Great. I believe you addressed this, but I'm going to read it anyway. Does MDAccess work with DOORS Next Gen also?
That's a great question, and yes, that's what I tried to highlight. It actually does not. DOORS Next is its own platform, which has its own OSLC interface for, and that's a different, completely different application, if you will.
Okay. Is TaskTop Sync compatible with OSLC?
That's a good question as well. Yes, it is. TaskTop Sync, and I don't want to speak for the TaskTop team, but yes, it is. It's interesting. When you create a connector for TaskTop Sync, you get an OSLC implementation for free for, I believe, CM, the CM dialect of OSLC, if you will.
Okay. Can MDAccess read from DXL attributes?
Sebastian, can you?
Yes, this is supported. So again, in case someone doesn't know what it means, well, you can define custom attributes in DOORS, and you can define them in such a way that they are computed. So you define a set of DXL code which is evaluated on each object to produce a specific value. So it's really a derived attribute which is calculated. And when you read this through MDAccess for DOORS, you get the value for each object. So yes, this is supported.
Thank you. Is there an evaluation version of MDAccess for DOORS?
Yes, there certainly is. We do evaluation licenses. We're always available to jump on webinars and give you a little bit more of a deeper dive, hands-on with you to help you with that evaluation.
Okay. Does MDAccess support creation and use of dialog boxes?
Sebastian, I assume the answer is no, but can you confirm?
Yeah, the answer is no, because the intent here is Certainly not to replace the DXL programming language. It's really focused on the data handling so that you can read data from DOORS and modify the data. The intent is not to replicate the whole DXL library and to have the DXL dialogues coming through Java. It's really focused on the data model of DOORS.
Great. Okay. A couple more here. I've customized DOORS with custom attributes. Can I access these proprietary values?
Yes, you can. That's what we're trying to show with that design risk variable. So one of the most common things, I've actually never seen a formal module that didn't have custom attributes. That, of course, is supported, and that was what we're trying to show in the demo.
Can I access view information and baselines with MDAccess?
Yes, you can. Just in the same way you have those getters, you can ask a view to get its object, so it'll apply that same filter that you have on your view, and it will return that subset of the objects. And the baselines as well. We had a couple of instances that I showed you. You can access the objects that are associated with an instance with a baseline.
Okay, then we have a question about licensing information, prices. Are they available on your website, or do we request them separately?
You should request them separately. As I've shown, we have a bunch of different ways of licensing it. So contact me separately, and I can give you those answers. And actually, maybe just a simple floating and fixed license price on the website. I'm not sure if it's accessible or not. But contact me directly, and we can figure out what makes sense.
Great. Well, it looks like that concludes our webcast for today. Thanks to Sebastian and Tom.